Hey guys, what's up? Eddie Alho here with kissanalog.com. Let me know if you guys like this kind of repair kind of videos, because I got a few things to repair around here, and how much you like to see and how much I should edit out. Okay, give me comments down below. Appreciate it. Let's jump into this part 2 video. If you didn't see part 1, I'll have the link somewhere on this down in the video description. Then the video, I think I'll try to link it. So yeah, watch that. And in part 1, I muddled my way through. First time I've tried to repair one of these, I was being extra careful. So yeah, and I didn't edit very much of it out. I left most of it in there so you could see me fumbling my way through something. All right, hope you like it. And let's put this, let's jump into part 2 and see if we can fix this thing, okay? So let's go 2.5. All right, so now we're charging. All right, so that charged up to 2.0 pretty quick. So, all right, so now we're charging this one. So we got a couple more, and he's still, okay, it's dropping down from an amp. Okay, 920 milliamps, 900 milliamps. So, okay, it's dropping pretty quick. So we'll let this drop down to the low milliamps, and then we'll go to the next cell. Okay, we'll just keep working our way down. All right, so where we are now is we were on these two, 2.5. Now we got to go to these two. So I'm going to set it up. It's 1.6. Let's get it set up. All right, I'm going to start at M1, 2 volts. That thing I had programmed there. All right, guys, got it set to the M1 2 volt setting that we had, and let's try that. Okay, it's coming up. Still stuck up 0.99. CC is still on. Constant current. There we go. Constant voltage. So 2 volts. So yeah, we'll charge up to 2, and then I'll, you know what? I'm going to go 2.5. Look how fast it's coming down. Okay, I'm going to go 2.5. Constant current. We're at 1 amp. Okay, it's going to drop back down. It's coming up. 2.49 to current 2.5. It should start coming down. There it goes. All right, cool. So we're going to let this go down to low milliamps, okay? There we go. I think we have one more after this one, right? Oh, maybe, I'm not sure. Maybe we have 2 more. All right, guys, I set the current up here to 2 amps, okay? And channel 1 over there is already 3 volts, 1.2 amps, so it's already dropped down. But the 2 amps kind of helped to catch up to these other 2 down below. And channel 2, you can still see it's 2 amps, 2.97. It's not got charged up to 3 yet. So, we're roughly putting in a little bit less than 6 watts. So not a big deal, right? And yeah, so still super safe current levels. But yeah, I'm just taking it easy. But channel 1 over there, look at that. It's already down to 1.2 amps. So it's dropping. And channel 2, while we've been talking, it's going to hit 3 volts right there. Okay, now the current, yep, 1.97. So now the current's going to start dropping. So we got them up to 3 volts. They're dropping. Now let's come down here and take a look. This guy's at half, 3 volts, 0.49, 3 volts, 3.9. So that's why I pumped the other 2 up to 2 amps just to kind of catch up to these, okay? So still really low current levels, but just being safe. All right, so just give you an idea where the voltages are. I'm going to read out the voltages from my KPS meter, okay? I'll just read these out to you. So from what we're charging right now on the matrix up here is this guy, that cell, 2.89, okay? So whoops, that's what it says. 2.899, so 2.9, okay? And then we're not charging B1 to B2 yet. So, okay, so let me tell you what that one is. 2.47. So we still have to charge this one, okay? but B3 to B4, 2.86, and that's this white and red one. And that's going back to channel 1 up there at matrix, okay? So we're still pumping that up. It's still going by 0.99 amps right now. Okay, so then we go from 4 to 5, okay? And that's 2.45, so we still have to do that one, okay? Then 5 to 6, okay, that's 2.8. And that's going back to channel 2 back up there, and that's still pumping out 1.3 amps. So that one's still cooking. It's still trying to catch up to the rest of them. Okay, so then B6 to B7, 245, so we still have to do that one. So after we do these 4, we still have some more to do, right? And then the last one we're doing right now is this guy at the bottom. He's 2.9, and that's the one that's coming from the matrix here, okay? So we still have a few more to do, but we're getting there faster now. We've got multiple power supplies helping us out. All right, guys, I decided to go to 3.3 volts on each bank. So I got 3.3 volts. This guy's putting out 1.3, and that's the bottom bank right down here. Okay, B7, that's the last bank right down here. Okay, so then this guy here, the matrix, he's already at 0.8. So this guy's still putting out 1.3. This guy's okay, let me see. I think the connections are bad. Whoops. Okay, sorry. That connection is bad. That connection to this one up here. So that's the first bank. And then the other one's the bottom bank. So this one's putting out 2 amps now. Dang, that one wasn't making a good connection before. So we're going to get up 3. And so I've got these things set for 3 amps, okay? Turn it off, say 3.33 amps. So it's 3.32 amps. So it's at 3.3. It's already going down. So it's just soaking up some charge to keep that voltage at 3.3. So they're just absorbing whatever the terminology you want to use. So 3.3 already, it's just absorbing. So once the current drops, then those guys are going to be kind of like saying, yeah, we're charged up to that voltage, okay? Everything's cool, nothing's warm. The one down here at the bottom is this guy. He's a 1.3 already. So that's this bottom cell here, okay? Then this guy up here, the white and red one right here, okay, right across here. That guy is channel 1 of the matrix up there. And then this guy, the black one, black and red. So this bank is channel 1. This bank is channel 2, okay? So set up the same way. Let's go look at them. Okay, I'll turn them off for a moment. 3 amps. Turn it on. 1.8, 1.9. So pretty close to this guy. So 3 of them are about the same, and that guy's got a head start. So he's only at 1.2. So yeah, we've got all these guys charging, and we're getting 4 banks charged. We still have this bank. So we have 4 banks charging, right? And we have 4 banks left. All right, guys, I have this guy. I put up 3.45. We're at 1.5 amps, 5 watts right now. And I bumped it up to 3.45. I just thought, what the heck? Let's just get these cells up to the neighborhood where they should be. Same thing with this guy. He's at 2 amps. He's running a little bit behind. And then let's go up here. We got something kind of cool going on here. Okay, that's triple output, right? 2 of them have high current and 1 of them is a little bit lower. But you can see 3.45 is set for all of them. The channel 1 over there, he's at 1.99. Channel 2 is 2 amps. And channel 3 is maxed out at 3.2 amps. So that's why the voltage is not quite 3.45 yet, but pretty soon it will be, and then that current will drop. So we got 5 cells out of the 8 charging. Okay, so I have, just to do 3 more. Okay, and I'm tempted to get my Uni-T in action. Get them all going, right? But okay, so right now that's what we have going on. All right, guys, I decided to get another one. I thought, well, let's go between 6 and 7. So 7 is tied to over here, okay? So we're going from black to red down here. So so if we go up here to this guy, this will be the black one, and that one is the yellow one that goes up there, okay? So I got this black wire there. Okay, so I got the black wire. All right, guys, so I got this black wire tied to the yellow one right there, okay? So you can see I got the black tied to the yellow right there, okay? And that's right there on my Uni-T, channel 1. And the red one will be tied to B7, which goes to over here to the blue one. So that's coming up there. So it's kind of wild. I got them stacked on top of each other. You got to be really careful. I used my multimeter just to double check myself to make sure it was positive, the voltage polarity and all that stuff is correct. But now, oh, here, let me turn on that channel so you can see what's going on. Okay, there you go. I set that to 3.45 just like the other ones. It's climbing, it's 3.2. I set the current limit to 3 amps, you can see that. So right now it's just under 10 watts, okay? So not much, it's climbing pretty fast. So once it gets 3.45, we'll see the current drop just like these others. Okay, that's the number 6 channel. We have 2 more battery banks that we need to charge. So I've got 2 more there. I wonder if I got enough leads. All right, guys, just want to show you something here. Put the meter here so you can see it. So I've got all these power supplies charging, right? But I was going to add 1 more on the Uni-T to get this guy. So I've started charging that 2.99. But then I thought, well, maybe I can also get this one. 2.77, okay? So I thought, well, I'll hook up 2 channels to get those 2. So it's kind of turned into an interesting thing. I had to chase wires, make sure they're going the right place. So you can see I've got 2 stacked here, 2 stacked here, 2 stacked here, okay? And then I could so I'm stacking all these power supplies on top of each other. Okay, so let's go up to look at Uni-T, the new guy we've drafted into this program. Okay, so there's the Uni-T. All right, so the interesting thing is I have that set up 3.45, 3 amp current limit too. Let me turn them on. I'll turn them on and show you what it looks like. Channel 1's 3.3, channel 2's 3. They're both at 3 because they're not up 3.45, so they're current limiting, right? But what's interesting about that is, watch this. I'm going to turn it off. All right, so watch these currents, for instance, okay? See where they're sitting? Now watch this. When I turn them on, they jump up. And at first I was like, whoa, what's going on? And so also here, let me show you something else. These 2 power supplies, only this one jumps up. Watch this one. I'll turn them on, turn them off. So I think what's happening, they're all isolated outputs, right? But I think what's happening is they're actually, since I'm stacking them on top of each other, it's given a pathway for the current to flow from cell to cell. So it actually has bumped up the current transfer, which is kind of interesting. It's like one of those things where I need to draw a picture to understand that. It's pretty wild. So at first I was alarmed. Then I'm like, well, I think it's okay. I think it's actually, I don't think anything's bad is happening. The current increased, but the current going to each battery is the same. It's just that the current to the batteries that are in between, you know, the cells in between are getting more current. I mean, it's just going through the meters and stuff. So it's just kind of wild. It's an interesting phenomenon, I think. Oh, and I think the reason why it's not affecting this guy is because he's doing this top cell. So he's kind of out of the so-called loop of the other ones, right? So he's out of the totem pole. So he's just operating by himself. And so when I turn on those power supplies over there, the Uni-Ts, it only affects these and this one down here because they're all kind of totem poled on top. So I think the current is just kind of going through each output and being measured, but not necessarily going through the battery though, if that makes any sense. All right, so with that condition, what I think I'm going to do is turn off the Uni-T supply up there, those two. And I notice those are the only two that affect these other ones because it ties two other adjacent ones. Just by happenstance, when I first hooked up these two and the three up there on the matrix, these 5 power supplies, it's funny, I got 3 matrix here, and a Uni-T here. But you know, when I hooked up these, I think it's because I got 1, 2, and then I've got some in the middle, and there's the ones that I don't have hooked up are in between. So the current on each one does not affect the other ones. So I like that because now I can see how much current's going into each bank. So instead of trying to get all 8 at the same time, I'm just going to do the 5. And, you know, I mean, thinking back now, I could have just been patient and did 4 and then the other 4. All right, so we're working on balancing these cells. And it's a new day. I didn't want to leave chargers on overnight without me here. All right, so we have 3.2 volts on this first bank. 1 to 2, B1, B2. 3.19, pretty close to 3.2, and B2 to B3. And noting black is at the top relative to the next one, 2.8. So there's what we need to do. And let's do between these two. Now I should get negative, I do, 3.2. Okay, so that one's looking good. Okay, let's go to 4 to 5. Okay, there's 1, 2. So 4 to 5 and 2 to 3. And how about 5 to 6? This should be negative. It is, okay, because I had my probes positioned that way. So it'd be 6 to 7. Well, that's only 3, so we need a little bit there. And yeah, that one looks good. So we need a little bit on this one. Okay, so we need, yeah, 0.2 more volts there. 4 to 5, we need some. And 2 to 3. Okay, let's get that hooked up. All right, so I got the first one hooked up white on 2, red on 3. And that is going to channel 1 up here. That's going to channel 1 right there, okay? All right, guys, so I've got that set for 3.2 volts and 3 amps, and I should be able to hit shift and channel 1 on. And man, okay, it's charging. All right, so up there it's saying 3.2, 1.8 amps, right? Let's stand back here for a minute. All right, so see the leads come through here? Okay, so let me show you what's going on here. And look at the meter there. So 3 volts. So we dropped 0.2 volts just getting over here, just because that 1.7 amps to this lead set. Okay, and then up here at the meter, up here the cells that we're charging, 2.9. So as the current drops, then, you know, the voltage will go up, the current will drop and all that. So we'll get less drop. So the leads are actually kind of helping drop level. It doesn't really matter because we're just pushing current in right now. And eventually it comes up to 3.2. But the point is we want to look here, not pay attention to what the power supply says up there, but what it says down here. Now, you know, I could have put these leads directly to it because they would reach, and maybe I'll just go ahead and swap that out and do that because, okay, let's just swap that out and see if that works better. All right, so I've got the leads from the matrix power supply right here. Let's take a look at this, and they're going right across these two terminals. We got 2.93, okay, and they go up to channel 1 up here at the matrix. Let's zoom in on that. All right, guys, so you see I've got channel 1, it's set for 3.2, what we want to charge to, and 3 amps limit. So let's see what happens. I'm going to hit the on button, and the way I turn on those individually is here. I'll just show you. Let's see what happens. That's going to drop down because of the cells that we're trying to charge, right? Well, not much. It's pushing 2.76 amps. Okay, let's look down here again. All right, 2.76 amps. Okay, 2.97 here. So it's going up. It's charging, but we're losing, you know, we're losing some voltage across these leads, right? Now, as the current drops, the voltage drop across the leads will drop. So we'll eventually get 3.2 here. Maybe I'll put 3.3 up there just to help offset some of the losses across the wire, okay? This matrix power supply is really nice, but here, let's go ahead and turn that off, and we'll go voltage set 3.3. Okay. Okay, so now it's 3.245. It's been pulled down, sucked down because it's hitting that 3 amp limit, 2.998. As soon as it drops below that, it'll stop doing that. Okay, so here. We'll go back and look at that in a moment. Let's come back down here and see what we're measuring now. Okay, so 3.26 is what you see up there on the meter, on the matrix. And we have 3.0 here. So we're dropping, you know, 0.2 volts across those test leads, which I'm kind of surprised a little bit because they're pretty thick, but the wire in them must not be that big. They don't feel warm at all because, you know, it's only dropping, say, 0.2 volts at 3 amps. So that's half a watt or something on that wire. That's not bad at all. But anyway, as the current starts to drop, it's still putting out 2.998 amps. Once this guy starts getting charged, then we'll see the voltage start increasing here and the current drop. Okay, so let's get the next cell. The next one is, would we say it's this one right here, right? Yeah, 2.4. Okay, so let's get that one going. All right, guys, so now I've got the leads for this guy here, our Uni-T power supply. I've got them set between right here. We're measured 2.4, okay? So it's set at 3.25, just slightly above 3.2, just count for some drop, but maybe I should even go a little bit higher than that. I'm gonna go just a little bit higher than that, go to 3.3 like we did up there, and we're set at 3 amps. So let's go ahead and turn that on. We're doing the 3 amps, and it pulled it down to 2.9. So, okay, let's go look at what it is on the terminals. I've got the same kind of leads that I've got. I forget which power supply I got these leads with, but they're the same leads as the other one we just looked at that I just connected. So we're going to see a similar drop. Yeah, see 2.6. So it's coming up, but again, we have some voltage drop because of the leads. Okay, but it's taken 3 amps, and the one up there is dropped down 2.5. Let me show you that. So it's already dropped to 2.5. So The voltage is clamped at 3.3 up there, but down here it's going to be different. Let's take a look again. This monitor, that is, it charges up. Okay, so that was here, right? So we got 3 volts. So down here we have 3. We're still dropping, 0.3 across the wires. And then on this one, 2.7, okay? Now you notice this light down here is red because it's constant current is actually activated. See, constant current. So we're clamped at 3 amps because it's taking all 3 amps. All right, guys, this last one from 6 to 7, bank 6 to 7. Okay, bank 6 to 7, I got this red and white wire. And remember, this one's the one at 3.0, okay? So what we're going to do, I think on this one, I'm just going to take these little wires here, just because they're short, and they shouldn't be any worse than the other ones I'm using so far. So I'm going to put these up here. It's 3.25, so I'll go ahead and do the same thing on this one. I'm going to get the voltage set for 3.3, and we're set at 3 amps on this matrix power supply. So let's go ahead and turn that on and see what happens. Okay, constant current's going. We're 3 amps, but it says about 3.3. So those little wires we're probably dropping some voltage on them, right? By the way, this one down here is almost coming up to 3.3, and it's 3 amps there. It's kind of, look at that. It's going between CC and constant voltage. So it's constant current, it's clamped here, but it's almost going to drop this current. So it keeps on bouncing. All right, so here we go. Let's see what we're seeing at these terminals. All right, so we're set at 3.3, and it's at 3.3 still because it's just dropping that voltage across the wires, but it's 2.9 amps, so it's a little bit below the 3, so the constant current's not on. So let's see what this guy's charging to. So he's coming up just a little bit. So he's not taking all 3 amps. That's good. He was charged a little bit higher, up to 3. So, okay, let's see what happens. All right, it's good to see this one drop below 3 amps. So the constant current's not on. Now it says constant voltage. In case it's kind of hard to see in that red. The red is a little bit harder to see. In person, it's not too bad. The red on this one is brighter, easier to see, probably on camera too. Okay, even though it says 3.3, we know that it's dropping voltage across the cable, right? So let's take a look, see what the cell's charged to. 2.99, so it's coming up. So that's why it's taking less current, because it is coming up. All right, guys, just to kind of show you what I've been doing. I dropped this to 3.25 because this bank here is catching up, and the one up there as well. Let me just zoom in and show you. See, I dropped that 3.25, and it's only pulling 1.12 amps maybe. So this one down here, it's 1.34. This one's still 1.8, so I left this one up because trying to let this battery bank catch up. Here, let me just show you these banks, what they're charging to. Yeah, I'm kind of doing this real slow, I guess, but that's all right. We're going to let these things soak. Okay, so 3.17. See, it's almost, the matrix up there is charging this bank here, almost up to 3.2. So that's why I dropped that down 3.25. And this one here, look at that. It is 3.2. So very little drop across the leads anymore. We're still pulling 1.26 amps. So, okay, now this lower bank, let me show you that one. Okay, that's 3.0, so that's why. So once that gets closer to 3.2, then I'll drop that down 3.252. All right, so that's the method to the madness here. Just letting this guy push a little bit more current to catch up to the other two. But essentially what I'm waiting for happen is these currents to drop in the milliamps, tens of milliamps, maybe 10 milliamps even. That means that the bank is pretty much soaked up enough charge at this voltage that it's happy. It's not needing any more current. That way, they're all the banks are closely balanced. All right, so here, let's go ahead and plug it in here and see what happens. Here, let's bring this over. Oh, the cord's just not quite long enough. Okay, we'll put this right here. All right, so moment of truth. We got the green light on. It's a standby. We want to see it go to red. This LED here turned on. So let's see if it does. Nothing yet. Oh, okay. This guy came on acting like it is, but this guy, it's like it's still not activated. Huh. You know, I would think there'd be enough voltage on this battery bank that, you know, that it would start to charge. Oh, hey, look. There we go. Red light. Okay, that's pretty cool. It says 268 watts. Is that what's going in? That could be right. 25.9 volts. That sounds about right. $278 watts, 26 volts. Says it needs 2 hours for a full charge. That's 2%. 26 volts. So it just toggles between them. And yeah, we don't need to turn on the AC. I still have the screen protector on that. That's kind of funny, but it's, yeah, I don't see a problem with that. I'm going to leave it on, I guess. Huh. All right, guys. So let's go ahead and let that charge. All right, guys. I got this thing set at 30 amp range. I like it because it has a smaller current range. And look at that. Let me freeze it. So that's what it says. We're charging at 10.57 amps in. So that sounds about right with the 278 watts, right? 26 volts. All right, guys, I think what the plan is, we're up to 5% already. It's just been charging for a few minutes. I'm going to let it go ahead. It says 2 hours. I'm going to let it go for about a half an hour. And then I'm going to check the cells to see if they're kind of balanced. Just make sure everything looks healthy and okay. I don't feel any temperatures or anything like that. Everything feels cool. But I think I'll get my thermal camera as well just to check it out. And then I'll put it back in the case and zip it all up and finish charging. Okay, guys, this has been charging for a little bit. Let's see where we are. I haven't really paid attention to the time. Oh, I think it's been charging for 40 minutes. So it says 1.6 hours left. It's up to 30%. So I think it's a good time to come in here and just take some voltage readings, okay? I'm going to try that. Wow, that charger's actually, you know what? That charger's actually pretty warm. I'd say 50C or something like that. It's pretty warm. Okay, so let me carefully go in here. All right, here we go. 3.37, almost 3.38, right? The next one, some of these are going to be negative signs just to make it easy. 3.37. 3.37. Wow, that's awesome. All right, KPS took a fall, but keeps on ticking. Stay. All right, where was I? Let's go back to this guy, 3.37. All right, that's crazy. Here, let me, this thing, okay, there we go. I had to get that level. Okay, let's go, all right, so let's get these voltages. Let's just start over. 3.37, 3.37 almost, 3.37, 3.37. God, I love this. 3.37. 3.37. Wow, this is just great. I feel the heat coming out of this fan, coming off the side of this. 3.37. Man, guys, this is looking great. 3.37. That is awesome. So these batteries feel like they're all charging the same. They're balanced. I'm not going to let it get discharged so much again. And it's at 31% right now. But you know what? Before I'm fully charged, I was thinking it might, this guy might want to kick on the fan to help keep the batteries cool. So I want to get it back in the case and all that stuff. And also, it's better, moving around the battery, doing all kinds of things when it's not fully charged. Okay, guys, this thing's put together with a whole bunch of these rods. Okay, this thing's put together with a bunch of these rods, okay? So some of them go in right now on the top side coming down. And what they do is I think they hold these two plates together. I think there's some glue and some other things holding this thing together, because when I took them out, it just didn't come apart like I kind of thought it might, so I could get to it. This thing is stuck on. There's same thing on the other side, same kind of plastic. It's got really strong tape on it. So I'm going to apply that back on and then put the screws on the back side. And then I think after that, you have this little rubber mat down here that fits into the bottom of this. And then that sits back down and all the screws go in the bottom to squeeze the other side and the bottom all back inside. So, all right, guys, this has 2, 4, 6, 8, 10, 12 of these screws. All right, guys, so 25.6 volts, 24 amp hour, 28.8 volts. I'm not sure why there's two different voltages. 24 amp hour, huh? Yeah, that's an interesting thing, but it's the E600LFP, 8 banks, 8 series 4 parallel. Okay, so 8 series 4 parallel. All right, guys, so I just want to talk about the reassemble process. Whoops, here's the bottom, okay? You can see all these inserts, okay? And then there's this here. And then there's this insert right here, okay? So I think this adds like a nice little insulation barrier. Yeah, it's kind of interesting, because then we have this piece, okay? And that goes down like that, okay? So now it turns out, so there's these pins here where we screw into them, okay? 1, 2, 3, 4 right down the middle, and then 2 on the middle here, 2 in the middle here. These 2 in the corner, this one here and this one here, we don't use, okay? And what we do is, let me show you, I'm kind of turning this around. So I'm turning the battery so we can kind of see it, but see these fasteners here? There's 4 that get screwed from this side, okay? And then the rest of them are all screwed in this side down into the, all screwed on this side down into the bottom, because the bottom will sit over back here, all right? So we have 4 in the corners, essentially, holding it down, and then all the other ones sucking it in, okay, to the bottom. So that way, so some of those 2 I showed you in the corners, they're just redundant because they're already in the corners here, okay? And this is what all those screws look like. There's 12 of them, okay? So 4 of them in here, and then 8 more on the other side. So yeah, they're, some nice, it looks like, actually, I just noticed that some of them are a little bit longer, different lengths. So it's probably the 4 that go into this top side are a little bit shorter, I'm guessing. Yes, there are 4 of them that were just like a quarter of an inch shorter than the rest of them, okay? So, yeah, and that's because they're not going all the way through into something like this. So they have to be, these have to be a little bit longer. All right, so you can see this where one screw in and the other one went in right here. Okay, so there's 2 screws and then 2 over here. And you can see these bosses, they actually touch, so you can watch to see them just make contact, and then that's tight enough because you don't want to crush them, right? So yeah, this assembly, I mean, everything's nice and cool from the charging. This assembly is really nice. Now it's interesting because it almost looks like you could put this in either way, but what I notice is, so this one has the PAM, so that one takes the long screw, goes in from the top, comes all the way through and tightens into that. So that's really nice how it sucks that in. And then on this side, it just has a short one, and the PAM is in the other side of the box. All right, I got to tell you, the mechanical engineering is pretty great. I put 2 screws in here, one, and one, and then I need to put, all right, and then I need to put these last 2 right here. And what was interesting is how well this thing fit. I thought it would kind of move around the box and I'd have to jostle around, but once I put it in, I started off with this screw and I just moved it just a little bit and I could hear it drop in, and then I was able to just at first just make sure they go in, and then once they're in, now I think I can just use this guy, and since it's not a real strong screwdriver, it's that Kaiweit screwdriver, I'll probably get them. Yeah, they feel like they're going down just, I mean, it was amazing how easy this lined up. Wow. Okay. So this is actually a really nice screwdriver. It's little Kaiweits. I think I showed it to you before, beginning of this video, but yeah, it's actually nice because it doesn't go crazy fast, crazy powerful and strip things out. It, you know, you can start it mechanically without having to hit a button or anything. You can just kind of turn it, and the torque is strong enough that I can do that. And then I can do the automatic thing, and then after I can use it mechanically just to tighten down because it didn't quite get it tight enough by itself. So guys, this case, and if you haven't seen the inside of the back of this case, if I haven't shown it to you yet, it's just nice and clean, clear. There's a little window here. I can see the circuit board, a couple contacts up there. You know, I'm assuming that during tests or something they can use those, but I like the plastic features, the long bosses, these little guys here that adds a lot of rigidity to the side of the box, the little bars here and how they do it all the way down the side. So, and this little pattern that they put on here is kind of cutesy. I mean, it's kind of funny, kind of showing where each cell, battery cell is, but wow, just so easy. And then look at that. That is crazy. So now I have these long screws that go in the corners that suck the top and bottom together. And then when I have the long one here that sucks the back end. So, and I have the little one that goes up in the front that you know, sucks in the front end. But man, these four, yeah, this thing is just, I think it's brilliant. I think they did an awesome job on this. I'm going to make sure this thing doesn't ever drain down to zero again, so I don't have to take it apart and do this, but that was awesome that I could recover it like that. And it does have the phone charger on top, which I just finally got a new phone after all these years, and so I think I can charge that. All right, guys, so I got them all in. It is kind of funny. There's that one hex driver on top, but I think it's because it's exposed and you can see it. And there's a UL safety thing that it's something like that they don't want you to have a standard screwdriver, flat or Phillips that some, you know, everybody has access to, because it's a safety thing. So they want to kind of make it harder for say that normal person to, with normal tools to be able to access it. I think that's why. So, all right, this is pretty easy to put back together, guys. Pretty simple. I've always liked the rugged feet, and now that I've taken them off, I see how clever it was to put them on. So, okay, got a couple more. It's just got that little slot that slides up in, and then this is slotted, and there's one up here in front right here, and then there's this little guy that just when they go on, they're on there securely, yet they're pretty easy to take off. And the cool thing is one fits all four corners. The way they designed it, you go the opposite side and it just works, in the opposite way. So anyway, pretty cool. All right, guys. So here we go. Moment of truth, right? Another moment. All right, put the charger up here so it's got some metal it's sitting on. No obstruction for the airflow. We got airflow on the sides if this guy wants to kick on. So just kind of help things run a little bit cooler. And there we go. It's saying 32% charged at this point, and we're hoping that light goes red again, which I have every confidence that it will. I guess there's just a timing thing that's going, checking the health of the battery, probably doing a bunch of things. And if it doesn't turn on, that'd be really gigantic disappointment that I've got it all back together. But come on, it's got to. Let's do it. There it goes. Yeah, that takes a good solid minute or two, right? Okay, 32%, 26.2, 26.4. It's up to 20. So the power ramps up, and it's saying 1 hour and 53 minutes, but we'll see. Once it figures things out and everything, we'll see how long. But all right, man, I'm happy to get this guy back in operation. I mean, of course, we'll have to test it. I think for the percentage to actually work correctly or accurately, I think you have to charge it and then discharge it so it can count coulombs and kind of know what a full charge is, I believe. So, not 100% sure about the 32% part of it, but it'll know when it's 100% though, for sure, because it's watching the voltage. The BMS does all that. So anyway, 274 watts. I was just waiting for it to settle down. Looks like it has 26.5 volts and 1 hour and 49 minutes. So we'll just let that sit here and let's do its thing. All right, guys. It's been a couple of days. It's been a week, actually. I've turned this guy on and off and played with it. The charger's holding. Everything's looking good. So, man, I'm going to keep this thing charged so it doesn't do that again. And, yeah, really like this thing. It's just a little bit bigger than that, than the EcoFlow that I have that's so easy to use. But I really like this thing, too. So I want to keep it going. And thanks for watching, guys. Let me know what you think. Did you like the video? Did you like these kind of troubleshooting videos? I mean, I didn't know this. This is the first time I ever troubleshot one of these unknown kind of, battery things. Guys, I used to design these things. But still, I consider myself a beginner on these things, So especially opening up the batteries and the BMS and all that kind of stuff. So, yeah, the inverters, the chargers, all that stuff, I'm much more familiar with. The BMSs, a little bit less, okay? Because the company I work for, we bought the BMS, put it on the batteries. So, I didn't design one of those. Well, I actually did do a board design for one, so... But that was a while back. So anyways, what do you guys think? 2 thumbs up to my patrons, 2 thumbs up to my members of my YouTube channel. And Danny, thank you so much. And like I said, I got a new Patreon. That's awesome because I haven't had a new Patreon member for so long. You become a patron for as little as $1 a month. I think you become a YouTube member by hitting the thing down below for like about the same. I think it's $1 a month. And you can buy me a cup of coffee, one-time thing down below, or a beer for a rant. I actually have a rant. You know, guys, I've kind of put it off, but you know, that whole Titan submersible, there's been a lot of videos on that. But on the engineering aspect, I thought about doing a couple videos on that, at least a rant about the engineering aspects. And, you know, it's been so much interesting information coming out on that. I thought about doing a few videos on that. What do you guys think? Let me know what you think. A year ago, I wanted to do it, and you know, with the people dying in that accident, man, I just didn't want to. I didn't want to, even though I had some rants on the engineering aspects, I didn't want to, you know, beat up on those guys. You know, I kind of, anyway, I just put it off. But now it's come back up, and a lot of interesting information. It's a lot worse than we ever thought it was. I mean, in all aspects, it's just terrible. In my humble opinion, it was a terrible company, and it was a terrible project, and there's so many things that went wrong in so many different ways, in my humble opinion. So let me know if you want to hear my side on that. I think I'm going to do a rant on that. So hey, buy me a beer down below. That gets me in a rant. I haven't had one of those for a while. Thanks, guys, for watching. Let me know what you think of this 2-part series on this repair of the Pecron. 2 thumbs up to Pecron. They gave me this about a year ago, I think it was, and I really like this thing, and I got to use it more. The EcoFlow is so small and easy. Then I have the big guy, but there are times when I need to use this, and I got to stop being lazy and use the EcoFlow. I got to use this some more often. All right, guys, thanks for watching, and we'll see. Long videos, right? Let me know what you think. Comments down below, please. We'll catch you next time.